I'm going to take the derivative of a whole mess of functions using the power rule.
Fantastic.
Yeah, power rule.
What we used to call the shortcut.
Well, it is one of the shortcuts. You're going to learn a bunch more. Absolutely. But this is the power rule here. And in order to use the power rule, you have to have your function written in this form.
Right.
Some number, in this case it's 3, it's a good number. Here's my x, so it's some number times x to some power.
Very
Hence,
good. The power rule.
The power rule, right. And it's really quite simple. You've done this a million times before. Really, all you're doing is you're multiplying the coefficient, 3, times the derivative of x to the 4th. Now, really, let me do this in a couple of steps. There's my derivative, f prime is equal to 3 times x to the 4th. Really, I bring that 4 down. 4, you know this routine. And then, what do I do to the exponent?
You subtract 1.
Subtract 1, 4 minus 1?
3.
3. You did that in your head, Miss
I
Stewart?
did.
That's brilliant. And now I'm just going to multiply these. So it's 3 times 4x cubed, also known as, can you do this in your head,
12x cubed.
Cubed.
Beautiful.
And that's it. Now, I know you're used to thinking of it as just 4 times 3x cubed, but really, in the long run, I think it will be helpful if you think of it as 3 times the derivative of this piece right here. Do you know what I'm saying? It's a
I know what
subtle
you're
difference.
saying. Right.
It's a subtle difference.
Yeah.
But that's really what's happening.
Now, if that weren't just a monomial, if you had like plus 5 times x squared or something like that, then basically I can just do the power rule for that term.
Absolutely. It would be 5 times 2x to the 1.
Right.
If I bring it right down here, of course, that's just 10x.
So the power rule I can do to each term in like a polynomial.
Each term in a polynomial.
Beautiful.
Absolutely correct. And the other thing is sometimes students will do the power rule and they'll forget to write f prime equals this. They'll just put maybe equals this.
Yeah.
And I don't want you to think that somehow this thing is equal to my original function. Clearly it is not. It is the derivative of my original function.
Very good point.
You know what I'm saying?
I know what you're
All
saying.
right.
Beautiful.
We're going to do a couple more.
All right. Sounds good.
We're ramping up a little bit, Ms. Stewart.
This looks like a good one.
Here we go. So here is my function. I have 2 terms here, and I'm just going to rewrite it in the form that we talked about.
Right. A coefficient
Just to be clear,
times x raised
this
to a power.
is not the derivative. I'm going to rewrite this. I'm going to bring this guy upstairs, and if I bring it upstairs, there, it goes upstairs like that. There's a 1 up top. X to the negative 2. I mean, there's really a 1 in front of it. I hope it's okay if I don't write that.
I think it's
all right. I'm going to bring this guy upstairs. This is really an x to the 1/2 power, square root of x. When I bring it upstairs, it becomes x to the negative 1/2 power.
Very nice.
Again, the 3 stays where it is. I'm just bringing the x upstairs.
So I just rewrote it. I haven't taken the derivative.
This is not the derivative. I think I said that part, didn't I?
You did. I'm just reiterating.
Thank you. This is not the derivative. I just rewrote it. Now, this is the derivative. So it's just going to be a 1, of course, times the derivative of this guy. Let's bring the negative 2 down. Subtract 1, so it's negative 2 minus 1. Getting more negative there.
Very nice.
Minus 3. It's 3 times the derivative of this. I'm going to do this in one shot, really. This negative 1/2 comes down, but it's times, I'm going to end up multiplying the 3. Negative 3/2? How's that working for you?
That's working.
3 times 1/2, 3/2. It's
yeah.
Negative, of course. Subtract 1 from negative 1/2. Well, so that's 1/2 minus 2 more halves. Coincidentally, also negative 3/2. Purely by coincidence, please, those of you at home, do not think that the coefficient is always, that just happens to be the case.
Yeah.
Do you know what I'm saying here?
I know what you're saying.
All right. So I'm almost done. I'm just going to...
Actually, you are done.
Well,
unless we say, hey, let's write this without negative exponents.
absolutely.
Because negative exponents are actually considered simplified.
Yeah,
often.
You're right. You're right. Depending on what you want to do next, but often it is handy, and I think it's a little bit easier to think about exponents when they're in their positive form.
Yeah.
So I am going to bring this guy back downstairs underneath the 2.
Very
so
nice.
that's really x to the positive 3 downstairs. This guy, I'm going to excuse me there. I'm going to make this a negative 3 over 2, and I'm bringing this guy back downstairs as well. X to the net, oops, now it's positive, look at that, 3 halves. Is that working for you?
Very nice.
Right, and notice I like to draw my fraction bars. It seems like a minor point, but I draw them flat so you can see this is clearly downstairs.
Yeah.
Sometimes students will kind of put it on the side and you can't tell if it's upstairs or downstairs. Clearly it's downstairs here.
Very nice. Nicely
Good.
done.
Thanks, Ms. Stewart.
Here we are. Another function to take the derivative. So again, it's a polynomial type, well, I shouldn't really call this a polynomial. It's kind of a function.
Yeah, it's 3
But
terms
it's
there
3
anyway.
terms is what I'm talking about. And it's not in the nice form that Mr. House was talking about, the coefficient times x raised to the power. So let's rewrite this. Again, just rewriting here, not taking the derivative.
Right, is that the derivative? No.
Rewrite.
Oh, you just
Yeah,
rewrite it. Got it.
All right.
Okay.
So this guy, I want to move that x upstairs. That 1/7 is fine as it is, right? So really we're thinking of the 1/7 as the coefficient. This guy is moving upstairs, so I'm going to plunk him right next door, because that's what upstairs is the same as. But it's going to be a -1. Does that make any sense? How
Yes, that's another good point. When you write an x next to your fraction like that, it's really the same thing as upstairs.
Exactly.
But in terms of taking the derivative, I think your best bet is really to write
Right.
coefficient times x to some power. That's how you want to have it written.
Right. And this is the same as this, but this is a more convenient form for
Terrific.
taking the derivative. All right, so here we go. Well, this guy, I just want to write it with an exponent. So a radical, of course, can be written as with a fractional exponent. So I think that's going to work there. Coefficient of 1. Minus, well, this guy needs to come upstairs and get rid of that radical. Let's rewrite that so that's going to be x to the 1/4. And that will be a negative since I brought that upstairs. Are we okay?
Yeah, we're good.
Let's take the derivative.
All right.
Power rule. We're
Okay.
going to do the power rule to each term. So here we go. -1, so it's the 1/7 times the -1. So I'm just going to do that in one fell swoop. X to the, I'm subtracting 1 from that -1, so it's -2. Plus, all right, here we go, 2/3 is coming on down. X to the, I'm subtracting 1 from 2/3. You can think of that as -3/3. 2 minus 3 is going to give me a -1. Of course, you have the common denominator there. Are we all right?
Yeah, that's good.
Okay, next term, I'm bringing that -1/4 down. I'm subtracting 1 from that. Well, I'm going to use the handy form of 4/4. So -1 and -4 is a -5/4. So let's clean this up and write it with positive exponents. All right, so this little guy needs to go back downstairs. So he's going to tuck on in next to that 7. So -1/7x². And I can put that negative wherever I want, right? All right, this little guy is going to go downstairs, tuck in next to that 3. And if you wanted, I could write that as a 3 times the cube root of x, or you can leave it like that, whichever you prefer. I have a double negative. Let's make that a positive. That little guy is going downstairs. Wow, we have a lot of critters going downstairs.
Yeah, what's going on downstairs?
A lot going on. All right.
That's great, Ms. Stewart. I like how in each step, like the first step there, you rewrote every term. Second step, took the derivative of every term. Third step, rewrote the derivative of every term. Sometimes students get themselves into trouble, I think, because they will maybe like take the derivative of one of the terms and like
Right.
rewrite another term and do it in the same step. It's like, no. One step, rewrite it. Second step, take derivative. Third step, rewrite again. Yep, every single term. That's going to work every time for you. Let's do
You
it.
know, that's amazing. My students do that too.
Yeah,
Yeah. So exactly right. Rewrite it, take the derivative, rewrite again. Boom.
that's where you want to go. Thanks very much.
Thank you.